Hello and welcome to Tech Anim Studios. In this tutorial, I will let you know guys how I have achieved this procedural walk cycle for multi-leg spider. As you can see in this video, there is not any keyframe or any baked animation used. All done is procedurally animating the legs and achieve this procedural walk cycle. And also you can notice that the legs are properly adopting the terrain. There is not any clipping or any feet sliding involved while moving. And you can also extend this logic to any quadruples or any multi-leg creature you want. So let's get started guys. So here I have a default third person project. All I have done is import this spider model from content example. So this is the spider model, and one thing I have also done is removing the third person mesh from the third person character blueprint and add this skeleton mesh. And I have also adjusted the camera boom and also adjusted the rotation rate and the walk speed of the character movement component. And here is the default behavior which I have right now. You can see we have the spider sliding around all over the place. So now our first step is to define our IK rig, which we can use in animation blueprint and then animate the legs on top of it. So first thing first, I will go to my spider model. I will right click and create an IK rig. I will call it IK spider, which is fine. Here we have this IK rig. So now we need to add a full body solver over here. So I will add a full body IK solver. This is missing the root. I will select the root and set root pawn on selected solver. Now it is missing the goals, and here we have this leg A. At the end of the leg A, we have this 1, 2, 3, 4, 5, 6 pawns. At the 6th pawn, I will right click and add a new IK goal. Leg A IK goal. And similarly for the leg B, I will add a new IK goal. And now if I right click, select this IK solver, right click and connect goal to selected solver. Similarly for this leg. And now when I move this goals, you can see my spider is full body IK is activated on the spider. So all I need to do here is adding the goals for the remaining legs. I will do it for all the legs. New IK goal, add to selected solver, new IK goal. Okay. So we have 8 legs, so we have 8 goals, IK goals, and now you can see whenever I move any of the leg, my remaining legs are properly connected to the goals. And if I move like 3 of the legs or any 4 legs, you can see the full body IK solver is activated. Okay, so our IK rig is done. What I have also done is inside the skeleton mesh of my spider, I have added 8 extra virtual bones. So you can add these bones, like I will delete the existing bones and add new ones. So from the root, we need to add a virtual bond to each of the leg. Here we have this leg A. I will call this virtual bond leg A. Here you can see we have leg A. So similarly, we need to add 8 extra virtual bonds. I will quickly add the remaining ones. C and virtual bond to D. There we go. Virtual bond leg B. Virtual bond leg C and virtual bond leg D. Now we have 4 virtual bonds. Now we need to add the remaining ones, remaining 4s, which is A02, this one, B02, and this one, also C026, and D, the last one. I will call these A, B, C, D, and similarly leg E and leg B, sorry, F. So we have these 8 virtual bonds now available. So now our iconic and virtual bonds part is done. Now we need to move on the blueprint logic. So I will close this iconic now, and here we have this PP third person character. What we'll do is browse this, and will add a scene component. Wait, we'll add a new blueprint script component under our mesh. So I will select the mesh, add new blueprint script component. I will set the parent to scene component, and then inside the blueprint, I will call this blueprint. Here we have the scene component. I will call this BP underscore leg. Okay, BP underscore leg manager. Now we have this leg manager scene component. I will select this and add it over here. Leg manager, done. I will call this leg manager leg A, and I will attach this leg A to my virtual bone leg A. Virtual bone leg A. Now you can see it is attached to my leg A. For debug purpose, I will add a sphere underneath it. Sphere for set this to 0.25. We just need it for debug purpose, and set the collisions to no collision. Here you can see we have this sphere which is attached to our leg A, virtual bone leg A. Now if I open my leg manager, so in this blueprint leg manager, in the begin place section, what I will do is get attached parent, which will be our this character mesh, because the component is attached to our mesh. So get attached parent will give us our mesh, and what I will do is get socket location. Socket location for now I will get the VP leg A, and I'm going to promote this to a variable leg position, right? And now in the tick section, event tick, what I will do is set this scene component location. I'm gonna get world location of this scene component and set world location. I will use an interrupt. We interrupt from current location to my target will be my get owner, get velocity, and multiply the velocity with our 0.5 value and use this get world to pass this over here. Get world delta seconds. Interrupt speed will be 5. Okay. Now if I hit play and you can notice that, oh wait, there is something missing. Let me see, what is it? Get velocity. Oh, sorry. We need to get this location of our current zone and add it over here. This will be our target location. And now you can see our sphere is moving, and all we need to do is just make our leg follow this sphere. So how can we achieve that? So in order to achieve this, what I will do is I'll create a new event, custom event, move leg. So when this event calls, I will get this leg position, current leg position, and I promote this to a variable that will be my leg start position. So this will be our leg start, and then we need to move it to a target, and the target will be our current location of the sphere. Here you can see we need to follow the sphere. The current is our leg location and target is our sphere location. So in order to do this, I need a variable, a time variable which we can use to interpolate from current to target. So for that, I will create a new variable. I'm gonna call this time and grab this time over here. So when my time is greater than, when my time is less than 1, I need to increase the time. I'm gonna get the time plus get the world delta seconds and multiply it, let's say, with 2, add it over here, and time is over here. Now if I hit play, you can see my time goes from 0 to 1, and we'll use this value from interpolation, and for that I will grab my leg position, and then I'm gonna use lerp from my real leg start position, which will be our current position of the leg, and target will be our get world location because we are following this sphere, and it alpha will be our time. There we go. And now if I draw this vector, draw debug sphere over here, radius will be 120, and now time will be 4 seconds, let's say. Leg position, get world location. Okay, what am I missing over here? Leg position. Okay, we need to call this function so from somewhere. So in order to get this working, I will go to my character blueprint, get this event tick, and here we have this leg A. I'm gonna call move leg. Let's say after delay of every 1 second, I'm gonna update this move leg. And now wait, move leg is gonna be over here. So once our time reaches to 1, we also need to reset the time back to 0 so that we can keep following 0 to 1 cycle. Here you can see, let me change the duration to 0. So we need to fix this leg position slightly. What I will do is inside over here, move leg. So we have this function. Let's create a new function as velocity. As velocity. What I'm gonna do is get this code from here. So if my length of the velocity is greater than 0, vector length is greater than 0, which means we have velocity. So I'm gonna use an output return view. That will be our. So if we have velocity, then we will, sorry, this function needs to be a pure function. So when we have velocity, what we will do is execute this functionality, time, increase the time when time reaches to 1, and set it back to 0. And now when I hit play, our leg start position is not getting fixed properly. So all we need to do is in order to fix our leg start position, I will create a new variable. I'm gonna call this replant foot. I'm gonna set it to boolean, and when we call this function move leg, we will set this replant to true. And once this replant sets to true, after this has velocity section, we'll add a new branch and check if we have replant is set to true. If replant is true, then move the leg. Once we reaches to the target, set the replant to false. So this will make sure that our move leg is only called once. And in order to move the leg further, we need to call this move leg function again, which is calling from the group character blueprint. So now if I hit play, and you can notice that our debug sphere is going from our leg current position to the sphere target position. See, and now we need to make the leg fall, not follow the sphere like a linear way. We need to follow it like a proper fit step. We need to change the z, and so that it feels like we are taking a step. So we need to add an z component here. So in order to do that, I will create a new curve. Uh, so we need to create a curve. I'm gonna go to the miscellaneous curve. We need a float curve. I'm gonna call this step curve. Float step curve. Okay, here it is. So all I need is two keys. One is set to 0 and set value to 0, and add a new key at 1, set the value to 1. Okay, so we have these two keys. I will smooth out this curve so that it properly feels like a curve. So we need to make a curve. We need to make a step, like start from 0, raise, and then goes back to 0. So in order to do that, we need a new key at 0.05 second, set the value to 1, and when we reaches to 1 second, set this value to goes back to 0. So here we have this curve is ready, and now if we need to smooth out this curve, I will make it like this, and from here like this. Okay, I'm gonna save this out. So we have this proper curve. You can set this curve to as you want, like proper set the curve tangents as you like. So here we have this footstep curve is ready. Now I need a new variable. I'm gonna call this footstep curve, and this will be our load curve, and the default value, sorry, the variable should be curve float object reference, and we'll use this float step curve, fit step curve, right? And now we need to integrate our z height into account as well. So what I will do here is, where our target location is, I will grab my float step fit step curve and use get curve, get float value, and the value I need a time, and time we have already here. So now it will give, this function will give us the value, and all I need to do is multiply that value, because we have this value from 0 to 1. So we need a proper z height. I will make it multiplied with the 75, right? And I will add that into my curve location. Break this, or make a vector. Okay, put it over here. I'll tidy up the code a bit later. Okay, now when I hit play, you will notice that our curve is, see, it feels like we have a proper fit step. So now we need to make our leg follow this position. So that is our next part. Okay, so in order to make our leg follow this position, we need an animation blueprint, and I will create, right click and create an animation blueprint of this spider skeleton. I'm gonna call this app underscore spider, right? And inside this animation blueprint, all we need is just an IK rig node. That's it. We will use an IK rig, which is IK rig spider. So we need to we need this IK goals to be available in our animation blueprint. So in order to do that, I will select this goal, and inside the details panel we have this expose position option. We can expose the position and rotation both, but we need only position, so I will expose this position out, and once I do that, you will notice that we have this leg position available. So I'm gonna call these goals to like proper name, leg A, leg B, leg C, leg D, E, and F, leg G, and one last leg H. I'm going to select all the goals and export this position out. Okay, save. There we go. So we have this, all the positions are available. Refresh. Okay. So we need to promote these all into a variable. So for now we're only working on a one leg. So what I will do is select our leg A, set this to, instead of additive, I'm gonna set this to white space, and then I will promote this to a variable, leg A position. So our blueprint is, animation blueprint is, part is done. Now I go to the character blueprint and select our spider mesh, set this animation blueprint class to our spider app spider. There we go. So our leg A is modified now. As you can see, we don't have any position, so our leg A is going to a 0, 0 location. So we need to set this variable properly. So inside my leg manager, what I will do is, we have this get attached parent. I'm gonna cast this to our cast to skeleton mesh component. So we have this, after this we have our reference to this skeleton mesh, and after that I will cast to my AVP spider, cast to AVP spider. Wait, I need to compile. Sorry, I need to get anim instance. Get anim instance of my skeleton mesh and then cast to ABP spider. There we go. And now I'm going to promote this to a variable. I will call this ABP spider. Now we have the reference for our animation blueprint, and all I need to do now is, inside my leg position function, I will grab this and set leg A position. Leg A position will be my leg position. There we go. Now when I hit play, there we go. See, our leg is starting to move. Okay, so let's say we want to adjust the speed of the leg, and all I need to do is just change this timer like 0.7, call this move leg function after every 0.7 second. You can see now it is taking it is too aggressive now. I will set this to 2 seconds. See, okay, I'm gonna set it back to 1. So now our leg A is moving. All we need to do is set this logic properly so that when we let go the inputs, leg should go back to the proper location. And we have this also issue when we begin play, our default value is not setting up properly. Okay, so in order to fix that, I will promote my alpha to a variable, leg A position alpha, and set the value to 0. And when I play, you can see our leg is at proper location. And now once we call this function update, I will set this set leg A alpha to 1 at that time. See, it properly start from the start position. Okay, now the next thing is we need to tidy up this logic a bit. So what I will do is, let me go through my notes. After has velocity, I will move this section a bit over here. So let's say once we have the velocity, all we need to do is add a sequence pin over here and a sequence pin over there for falls as well. Let's move it a bit over here. Okay, so inside this first sequence, what I will do is check if my replant is valid. If my replant does valid, then I will move this whole functionality over here. If time is less than 1, so this function is over there. Section over here, there. Okay. So once my value, once time reaches to 0, reaches to 1, and we'll put a branch over here and check if we have the velocity. So if we still have the velocity, then what we need to do is set the time to 0 and set the replant to false. And if we don't have the velocity, then do nothing. So let's say we don't have the velocity, this function will evaluate calls from here. So from this point, once we don't have velocity, we'll use a do once node, do once, which will trigger only once. And all I need to do is set my leg position back and replant to true and time to 0 again. Here we go. There. Okay, and once we have the velocity, we'll reset this pin back, and After setting this up for, after setting this value for once, we will call this functionality again, replant foot. Here we go. Okay, right over here, like so. Looks a bit cleaner now. Move it all over here. So now let's hit play and see the results. See, when I let go the input, leg goes back to the start position, but it still stuck at the position if he is middle in the air. Okay, now we need to fix this issue. If we let go the input, once the leg is middle in the air, we need to goes back to this leg position immediately. So in order to fix this, let me see. So once we don't have velocity, we reset this, call this function once, select start position. Okay, so our replant foot should be true once we don't have velocity, and then we'll call this function again. So now when I hit play, see, as soon as I let go the input, my leg goes back to the start position. Great, this is now working fine. So our one leg is moving, still we have the issue like this. We are, once we start moving, our leg is not start immediately. Okay, so in order to fix this issue, what I will do is inside my character blueprint, I will create a new for event called custom event and call all these move legs and put this over here. So we need to call this function properly. What I will do is get velocity. So if we have velocity, get length of that vector. Length. So if we have velocity, then what we're gonna do is I'm gonna create a new variable start. I'm gonna call this start moving. Set is to false. Okay. So once my velocity is valid, if we have velocity, then put a branch over here. So if the start moving is false, which it is at the begin play, what I will do after delay of 0.2 seconds, I'm going to set this to true and call my event legs move legs, which will this function. And once we have the velocity set, we don't have any velocity, I'm going to set this variable to false again. So this will call, this functionality is only call once we start moving, only this is call only once. After that we're gonna use our same functionality which we have previously, directly call move legs. Here we go. So now once I hit play, you can notice that, wait, there is something missing. Start moving is false. Once it's false, set it to true and move legs. Okay, I don't need this delay over here anymore. I will put this delay over here. 1 second, start moving. So this function will only call this leg, and now you can notice that immediately my leg starts to move, and when I stop, my leg goes back to the initial position. So our one leg is fully functional now. So now we need to make our all the legs to follow the same principle and follow follow the same principle and starts to move as we want. So in order to make our all the legs move, I will open my leg manager, and we have these hard-coded references, hard-coded values. We need to parameterize this function. We will use this BP leg manager as it is, and we will parameterize our values so that it will work for all the cases. So first thing first, I will create a new enum. I'm gonna go to blueprint enum. I'm gonna call this e underscore spider legs, and we have this. I'm gonna call 8 values. So we have this 8 value. I'm gonna call this leg A, leg B, leg C, similarly leg B, E, F, and leg G, leg H. Okay, so now we have our 8 legs promoted. What I will do next is create a new variable inside my BP leg manager which will represent our legs. I'm gonna call this, let me go through my notes. I'm gonna call this, wait a moment. I'm gonna call this selection, select leg. Okay. And the type will be my e underscore spider legs. Okay. Now, so inside our leg manager, we have this variable select leg. We can select which leg it is. So we need to select that in our BP character. So if I select my leg manager, which is our first leg, we have this select leg option. I'm gonna remove all my existing variables. We only need to visible our variable which are necessary inside the character blueprints. Currently our all the variables are visible. So in order to do that, I'm gonna select all my variables, and I'm gonna set it to private, 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 private. Now we have only one variable which is public, which is select leg. And now if I go to over here, character manager, we need to select our leg. So this represents our legs. So currently it is set to leg A. So if I promote this to, if I duplicate it, call this leg B. I'm gonna remove my sphere for now. I'm gonna duplicate it for leg C, leg D. So we need to have 8 legs now. Oh, wait, what is this? Here. Okay. Okay. Leg D, leg E, leg F, G, and H. So now we have our 8 legs are here. We need to select each individual leg and select this, set this property properly. Leg A is leg A, leg B is leg B, C is leg C, D is leg D, E, F, and G, and H. So now we have 8 legs are ready. Now we need to select the parent bones as well. So leg A parent socket is leg A, leg B's parent socket is BB, leg B, sorry, leg B, C socket is EB leg C, D socket is BB leg D, E, F, G, and H, the last one. So now we have 8 legs which are properly attached to their respective legs, mutual bonds. So our character blueprint is character blueprint part is done. Now we need to go to the leg manager and parameterize these things over here. So we have this hard-coded socket location. That socket will be leg A. We will use a select over here and use this select like so. So we need to have our proper names. Leg, sorry, VB leg A. So I'm will I'll just confirm we have this naming convention leg A, leg B. Okay, right. So I'm gonna let's just copy this first name and we'll duplicate the existing ones. B, C, D, E, F, G, and H. So this represent our each legs. So let's just draw debug sphere in order to verify our locations properly. Debug sphere I'm gonna use to you. So on begin play. See, our all the legs are there, visible now. So this part is ready. Now we need to parameterize this, which is I will copy paste the same thing from here to here, like so. This part is ready, and now if I hit play, let me wait. We need each leg to follow their respective position. So in order to do that, we only have this leg A position at the moment. We need to promote all of these variables to their respective values. So now I will promote this leg B position, leg B alpha, leg C position, leg C alpha, D position, D alpha, E position, and then E alpha, wait over there. So working with 8 lakhs sometimes is a bit redundant. Mm. So our 8 variables are ready. All we need to do is select all the alpha set to 0. Can we do multiples at the ones? I don't know. 0, 0, 0, 0, and 0. Okay, done. So these are all promoted. One thing remaining is we have all these goals, which lag goals set to additive. We need to set those to world space in order to follow uh, the vector, the position properly. So I need to set these to world space. World space, world space, world space, world space, world space, and world space. So all are set to world space now. Okay, our leg A is not at the right position. What is wrong here? Let's just confirm. Leg A position. Okay, the issue here is we are parameterize everything, but we are always calling this leg A, setting up the leg A position for only leg A. So we need to set this position individually. Like we have 8 legs, we need to set the positions accordingly. We are currently we are only setting up leg A position. So we need to set each leg position. So in order to do that, we have this select leg. What I can do is switch. So for my leg A, this section is valid. As you can see now, if I play, you can see our leg is at proper position. See, and I will debug, just remove this debug from now. And for the remaining legs, we need to set leg B position, set leg B alpha, I will do here is use this is set it to 1 now. And for leg C position, leg C alpha, leg D position, leg D alpha, leg E position, leg E alpha, F position and F alpha, G alpha, sorry, G position first. Now only one is remaining, H position. As I mentioned earlier, working with 8 legs is really redundant work to do all the time. So I will connect over here, set the alpha to 1. Set this position based on the leg position. Okay, this part is done. We need to connect D to D, E to E, F, sorry, F, G and H. I will move it something like here. Okay, we need to set the alpha to 1 for each. Okay, this part is done now. Now when I hit play, our legs are interesting. Okay. What is wrong here now? What is wrong here? What is wrong here? All connected with word space. That is fine. This is fine. This is fine. This is fine now, and I leg A position to A, B to B. And C, D, A. This is so much mess. There's so much mess over here. Okay. Maybe I need to promote this to a variable function and call set those based on the functions. But anyways, now let's find out what's wrong here. Why the legs are not. This is strange. We'll fix this one as well. So the issue here is we have not set up our iCarig properly. So if I open my iCarig, you can see we have this iCarig which we have set up. So our root bone for the full body IK solver is root bone, which is the top of the root. And if I open the skeleton hierarchy, the virtual bones are also the child of the root. So due to that, once the virtual bones get separated, the root gets separated and mesh keeps moving up and up. And in order to fix this, all we need to do is just simply select this full body IK solver, right click on the first child of the root, thorax, and right click, set the root bone on selected solver. So now our root is updated with this thorax bone, and once I hit save now, and if I hit play, you can see my mesh is not moving up and up, and only our one leg is moving. So the issue is have got fixed now. All we need to do here is so right now our only one leg is moving. So now we need to move our all the legs similarly as we have moving our one leg. So if I go into my third person blueprint, and similarly if I select my B bone, set it over here, or E bone, set it over here, and just for testing purpose, if our all the legs are moving, you can see 3 of the bones are moving. So now we have the ability to move each leg individually. See, our only B leg is moving, right? So now our leg manager is properly set up. We don't need to do currently anything over here. So we need to make a sequence, like first move A leg and then B, C, like to make a proper walk cycle, like four legs first, then four legs, like so that like an biped, like a human walk cycle. Raise first leg and then once the first leg planted, raise second leg. So we need to make a sequence for this. Okay, so for making this sequence, what I will do is inside I have I'm grabbing my A, F, C and H one and calling from here. So first I will move four of my legs. We are moving legs at after every 1 second, right? After 1 second we are moving. So I will promote this delay to a variable now. And once we move four of the legs, I will delay for multiply 0.5 and move the remaining four legs after this delay. We have A, C, now we need B, D, E and G. If I put all of these over here, now you can see we have made a sequence. Now if I play, okay, it's not properly updated because we need to add a delay over here. Delay and then okay, nice. Now you can see our spider is moving, like four of the legs are moving, but it looks static, like complete static, means four leg, then next four, then next four, next four. It looks like a complete robotic feel. So we need to break this robotic feel. But how we can achieve this? Okay, so in order to do this, inside my move leg, what we can do is we will add another delay over here. That will be our start delay. Okay, I need to promote this to a variable, start delay. So once we call this move leg, we have a local delay as well. Like when we are calling this function move leg after every 1 second, after calling we have a local delay so that we can differentiate each leg accordingly. So we have this local delay over here, and I will set this to not private so that we can modify inside over here. So if I now grab my leg A and I'm gonna set this local delay to 0. For F, I'm gonna set this local delay to 0.2, and for C, I'm gonna set the delay to again 0. Like set this delay to 0, then grab the next curve, which is F. Let's say grabbing F, set the start delay to 0.2, grabbing C, set this to 0, and grabbing H, and then again set the weight to 0.2, C to 0. So now we have A and F have 0 delay. A have start delay of 0 and C have start delay of 0. Sorry, A and C have start delay of 0. F and H have start delay of 0.2. Now if I play, you can notice that the four legs have some sort of offset. We will add this delay to remaining legs as well. Like B, set this to, wait, I will copy it from my notes. Set this to 0. And for G, I'm gonna set it to 0.2. B 0, G 0.2, again E 0 and D 0.2. Now you can see we have some sort of local delay as well, which breaks the whole immersion of the cycle. See, if you can see in proper slow-mo, like I'm playing in slow-mo. So all you need to do is just make a proper sequence when to call these legs properly and put the right delays so that it works properly. You can parameterize this delay based on the speed. Like let's say currently my movement speed is my walk speed is 120. So let's say 120, set the delay to 1. So once we, let's say now we need to start running, we can set the initial delay to 0.5, 0.75, like so. Now you can see we have this legs are moving really fast. So you can parameterize these things based on the speed. See, now the legs are moving fast. If I set this to initial delay inside the character to 0.5, this will really the legs are moving really fast now. Sorry, I need to set it to a start duration to 0.5. See, now they are moving really slow. And now if I put it back to 1, so you can parameterize the stuff based on the actual speed. Okay, so now the legs are moving, but we can also parameterize one more thing, which is the z height of our of the step height of z. So we have this. Let me at begin play. What we can do is we have this static z height promoted to a variable z height of z height step. So currently it is 75. What we can do is make a random between random floating range, let's say 40 to 80. So some of the legs have different z height. See, so this is also, we can also break the robotic feel using this variable as well. What I'm going to do is set the random range to 50 and 75 for now. Okay, so our spider is moving really good, like we have a proper procedural walk cycle. Now what we need to do, one more thing is adjusting it based on the terrain height. So now if we're moving over terrain, you can see the legs are not adjusting properly. So this is really easy. We can also fix this. All we need to do is we are setting the world location here. All we need to do is setting the world location based on this sphere trace. So what I will do here is I'm gonna right click and promote this to a function, collapse to function. I'm gonna call this set scene component location, set it to pure, and over here what we need to do is line trace by channel, and what I'm gonna do is get this current world location, get world location, and what I will do is add, let's say 200 in the Z, and then add 200 in the Z, that will be start, and adding, let's say 400 or 450, let's say 600 in, that will give us a proper line trace location. So once it gets hit, we are making sure that it properly gets hit to us surface. And over here we have this interpolate function, which will be used as it is. All we need to do is just set the Z properly. So I'm gonna make vector over here. The X and Y we will be used from here, from the previous, and the Z will be my based on this hit location. Now if I hit play, and you can see that we have the traces already. And now once we spawn our spider over here, voila, we have this ready. Spider walk is ready. Okay, so this is it. I believe we have everything is ready. Everything is in this video we have covered so far. All is parameterized now. So I hope you guys have liked this video. Let's say if I delete, sorry, if I delete this and set this start over here. Now if I play, let's just set this to the hide, draw debug type to none, and now when I hit play, also set this capsule to hidden in game. Okay, now our procedure spider box is ready. Everything is procedural. You can see our legs are properly adapting the terrain. There is not clipping. We can see. So that's it for this video, guys. I hope you like this one, and see you in the next one. Bye.